All right, guys, recall your 6 trigonometric functions. You got 3 primaries. Your 3 primaries are sine, cosine, and tangent. Each one represents a side length proportion. What sine, cosine, and tangent are doing, they are saying if I know the angle between 2 sides, I can always determine the proportion that each side is to each other as long as I'm creating a right triangle. So the first thing we need to take a look at really quick is we have the opposite side of the angle. We need to identify opposites, adjacents, and the hypotenuse, which is easy. So the opposite side of an angle is a side that does not share any vertices with that angle. So right here, we have a triangle on your note sheet. Ladies, trig is a place where a lot of you guys struggle. I don't want to hear about your struggles if you guys can't be silent while I teach. Okay? Okay, so we have our triangle ABC. And I want to talk about what's considered opposite. So when I say an angle, it's very easy. As long as everything's labeled, it's easy to say what's opposite. What's opposite is whatever does not contain that letter. So what is opposite angle B? What side? A to C. That's it. Because A to C does not contain the letter B. What is opposite of angle A? C to B, right? And we're not going to say what is opposite C. Why? Because what would be opposite of say? Say. Okay? AB, which is the hypotenuse. So it has its own special name, right? So what's opposite the right angle, so what's opposite C is AB, but what is opposite the right angle is always the hypotenuse. So it's important to always be able to identify the hypotenuse of any right triangle. First thing, look at a right triangle, identify the hypotenuse and the right angle.
You said that was adjacent.
I haven't said the word adjacent yet.
I know, we were just guessing.
Oh. So the adjacent side is a side that connects from the angle that you're talking about to the right angle. To the right angle. So what is adjacent to angle A? A, you include the angle A to C. You go to the right angle. That's all there is to it. What is adjacent to angle A to C, because you start at the angle you talk about, and then you go to the right angle. Question, Aaron? It will connect, yes, in right triangles, we're always talking about adjacent sides will connect to the right angle. So adjacent to angle B is BC. And once again, we don't, and the hypotenuse just stays the hypotenuse, okay? Right, so you can't, what's adjacent to angle C you're saying? Right, there's not going to be an adjacent to the right angle because you don't know which one you're talking about. Right, because you can't say it's going to go from the angle you're talking about to itself. Yeah, you don't do it.
So we just say no adjacent?
No, because C is the right angle. C is not over what we're talking about because it doesn't tell us anything. So we have to be talking, right now we're dealing with right triangle trigonometry. Right now we're dealing with right triangle trigonometry. So the right angle is given. The two unknowns are the non-right angles. So we don't ever need to talk about that right angle C. It's already talked about for us, right? Because we're talking about right triangles. So the 3 primary trig functions, if you don't recall, or if you've never been taught them, are called sine, cosine, and tangent. And Mr. Bates always says, what about them? Don't say sin, cos, cos, or tan. Okay? You say the full word. Just like when you guys are going through your homework, right? Or the notes, and it says this. Nobody says x1. They say example 1. No, you don't. Okay. So sine, cosine, and tangent are those abbreviated type of words where you say the full word anyway. Right? When you guys are coming down the road, right? You guys aren't like, you don't look at our street name and go, this is River's Edge Road. Okay? This is River's Edge Road. So, sine, cosine, and tangent. Sine, cosine, and tangent are said full sine, cosine, and tangent. All right. So, Aaron, make sure you're tuning in here because we have what sine, cosine, and tangent are, and it's written out in full words down here. The sine of an angle is written sine of, and it's always going to be a lowercase Greek letter. Well, not always, but it should be for good notation, a lowercase Greek letter. Sine of an angle, in this case I used alpha, is going to be the side opposite alpha divided by the hypotenuse. Okay, it's at the bottom of the page, yeah. Sine of alpha is equal to the side opposite alpha divided by the hypotenuse. Cosine of alpha is the side adjacent alpha divided by the hypotenuse. And the tangent of alpha is the side opposite divided by the side adjacent. Tangent is also referred to as sine over cosine. Albert's passing out. You all right, Albert? Okay. Tangent is also sine over cosine. That is acceptable forever and always. Okay. Now we have a mnemonic device that, once again, you should recall. SOHCAHTOA. Right? So sine, S, is opposite over hypotenuse. We're just getting rid of all those words. Cosine, C, is adjacent over hypotenuse. Tangent, T, is opposite over adjacent. And we have SOHCAHTOA. We all right, Sarah? Victoria?
I just laughed. He was singing. He was singing us a SOHCAHTOA song.
Would you like to?
There was a video we used to watch for this last
By all means.
Okay, wait.
Hold on, let me get closer so the mic picks you up.
Oh my goodness. It's not really, it's just like sing-songing the words. It just goes, he goes, SOHCAHTOA, 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 sine, opposite hypotenuse, sine, opposite hypotenuse, cosine, adjacent hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, tangent, opposite adjacent, tangent. And then he has a bunch of other lyrics to it, but I don't remember them.
My life feels diminished.
Can we watch a video one day?
Maybe.
If I can find it?
Sure.
It's the best video ever.
Ever. Okay. All right, guys. So example. Let's go to that example in the text, or in the notes in the text. The text. I've got a nice gigantic triangle written out for you guys. I don't know why my triangles are so huge on the paper. We have 610. Oh, probably because you guys are going to spend so much time writing to the right side of that on the paper. We want to get our trig functions for this. All 6. Oh, for angle A. Please keep in mind, I could ask you angle A, I could ask you angle B. I'm just not going to ask you about angle C. I can ask you about angle A, I can ask you about angle B. I just can't ask you about angle C. You just look on the verge of giggling every time I'm looking over at you, Victoria.
I don't know what she's giggling about this time.
You're making me nervous, Victoria.
She's talking to herself because no one said anything.
All right. So let's jump around here. Manny. All right, let's do the sine of angle A. So normally it's sine alpha, but alpha is always referring to an angle, so we're doing the sine of A. Right? Ah, that's the cosine of A. Okay. So, let's really quick here. X, but let's solve for, how do we get that value? Yeah. Okay. Aaron jumped in. I don't know if you heard him, Manny. Okay. Aaron jumped in. He said that we're just going to use Pythagorean theorem. We have a right triangle. So a squared plus b squared equals c squared. So let's find that missing side really quick. Then I'll come back. I thought I already had all sides written down, but I don't. So I'll come back and I'm going to have you solve it in a second here. Watkins, what's this? So I get a squared plus 6 squared equals 10 squared. Yeah, sure.
So it's then a squared plus 36 equals 100. Subtract the 36 on both sides. Square root both sides, get a equals 8.
Okay. So, yes.
Isn't there like the short answer? Like if you see like certain numbers, there's like a pattern. So like 3, 4, 5, 6, 8.
And this is a double of 3, 4, 5, so it's a 6, 8, 10. There's also a 5, 12, 13. Manuel, so what's our sign? Which reduces to? Four over 5. Okay. So my sine of A is 4 over 5, opposite over hypotenuse. Okay, my cosine of A, he said that a second ago, was 6 over 10, which reduces to? 3 over 5 is correct, Sarah. And then what's my tangent of angle A? 8 over 6, which reduces to? 4 over 3. Okay. Tyrell, just for the heck of it, why don't we go and do sine, cosine, and tangent of angle B?
Mr. Bates. I'm sorry, but I'm not getting the 8.
For tangent of A?
Or A, yeah, or sine. I'm not getting where you got.
Oh,
the
it's
8.
the Pythagorean.
We use the Pythagorean theorem to solve for the missing side. Pythagorean theorem says a squared plus b squared equals c squared, where c is the hypotenuse. So I just plugged in a squared plus 6 squared. This is my opposite side, so I'm just calling it letter A. Okay, so a squared plus 6 squared equals 10 squared, 36 and 100. Subtract 36 from both sides, I get 64. Square root, I get 8. Okay. Tyrell, sine of B, which reduces to 3/5. Cosine of B, tangent of B, reduce it. 3 over 4. Destiny, can you tell me? Destiny, can you tell me what? Do you notice a relationship between my answers here and my answers here? Yes, you do. Open your eyes. You got this.
Okay, well, the sine and cosine, those are both over 5, right?
Yeah.
And the bottom are both over 5 too.
Mm-hmm.
That's probably wrong.
No, that's an observation. I'd like it to be a little bit more concise.
Oh, well, that's all I have for you.
You got me. You got more.
I don't think I
I think you do.
do.
Not only they both have 5 on the bottom, but what else?
Sarah looks like she has an answer.
Victoria, why don't you do that motion you just made at me toward Destiny?
Oh, they're opposite.
Yeah, they just swapped. They just swapped. Sine of B was 3/5. Cosine of A was 3/5, right? Cosine of B is 4/5. Sine of, but tangent had nothing to swap with. So what happened to tangent?
Oh my gosh, it's the reciprocal.
It is the reciprocal. Look at all those observations you made. Give yourself a pat on the back. All right. We good, guys? All right. Great.
But what does that mean?
It means that if you find one of them, you can find the other one without doing any work. That's the observation you get. Yeah, in a right triangle, they're always just going to swap and the tangents are going to flip. Absolutely. So we don't need to do all that work and reduction a second time through. Right. All right. Cosecant, secant, and cotangent are just the reciprocal identities of the primary functions. So they're very easy to get. Just remember, though, that cosecant goes with sine. Cosecant is the opposite sign. So if you want to think about, not only are they reciprocals in that you flip the fraction, but they're also reciprocals in that Cosecant, which starts with a C, goes with sine, which starts with an S. Right? Secant that starts with an S goes with cosine, which starts with a C. And then tangent and cotangent are the only ones that have the word tangent in it. So they are just flipped. So quick, easy question. Quick question. If cosine of theta is 3/5, what is secant of theta? If cosine, is that what I wrote? Yeah. I don't know why I put if equals cosine. That equals shouldn't be there. If cosine theta is 3/5, Aiden's completely right. Secant of theta is Sada. It's okay. All right. Amaya, 5/3. That's super basic, guys. If you're dealing with the reciprocal to the main one, you just flip it. That's it. Yeah, see it?
Mr. Bates, I don't like this.
Why?
Because does it have anything to do with the lesson we learned yesterday?
No, they have to be joined together.
Oh, they're not joined yet.
They're not joined yet. I've got to teach you this piece, then I'm going to teach you this piece, then I'm going to teach you this piece, and then you're going to together.
But except they're gonna be like.
Yeah, just like that.
They're going to be much more melodic and like a ping pong ball. They're going to be a TikTok by Sarah DeVries. Alrighty. Find all 6. So right here. Just going to scroll this up. Last easy question. Is that close enough to the way it's supposed to look? There are 7 questions. The numbers with the pictures go. You guys are just so off today. All right. So Sada, the same thing here. We're gonna have to use the Pythagorean theorem. We don't have. Which one's the hypotenuse here, guys? Right. No. Careful. The hypotenuse is always opposite the right angle. What's opposite the right angle? AB. This is my hypotenuse. So it's going to be a squared plus b squared equals c squared, where c is the hypotenuse. So I know A. I know B. I don't know C. I know A. I know B. I don't know C. And I don't even know if it's going to be a pretty number. So we get 64 plus 169. And square root both sides. Now 233, 2 doesn't go into it, 3 doesn't go into it, 4 doesn't go into it, 5 doesn't go into it, 6 doesn't go into it, 7 does not go into it, 8 doesn't go into it, 9 doesn't, 11 doesn't, 10 obviously doesn't, 13 does not. 17 doesn't go into it. Okay? So I'm pretty sure once you pass the square root of it, once you pass 15, there's no reason to keep on checking numbers to see if we can reduce this. So my hypotenuse is simply the square root of 233. That's fine. We're going to do this for angle B. We're going to do this for angle B, so we're going to do the sine, cosine, and tangent first. Sine, cosine, and tangent first. Then we'll do the cosecant, secant, and cotangent. Now what's nice, 8, 13, and square root of 233, there's going to be no reducing here. So, Sarah, what is the sine of angle B? 13 over square root of 233. Okay, what's the cosine of b? Yeah. No. Eight. No. Okay. What's tangent of b? 13 over 8. Okay, guys, can we have a square root in the denominator? You know the answer to that. No, we need to rationalize it. But we've got a very easy algorithm. Can somebody remind me, raise their hand please, and remind me of the very easy algorithm we can use to rationalize the denominator? Indigo? Yeah, I'm going to multiply the square root on the top and the bottom, but what does that result in? What is the end result? Over 233. Right, guys, so when you have the square root in the denominator, don't forget that the easy algorithm, the square root simply joins the numerator. This is really nice when nothing reduces. And then the square root's just gone in the denominator. The square root joins the numerator, and then the square root is simply gone in the denominator. Yeah. Yeah, we're multiplying the numerator and the denominator by square root 233 over square root 233, but we don't want to take up all that room, and at this point in our lives, we really should have this shortcut down.
I was feeling so good about yesterday, and now.
And now things just went downhill.
I know, but
And then you have to put them together.
Destiny, you're going to now finish off the last of it so I can build your confidence again.
I don't have any to build off of.
Destiny, it's there.
I don't think so.
We'll pull your confidence from other areas to build your math confidence.
I don't have any of that either. So.
No, none?
No.
You have no confidence in any of your abilities whatsoever?
No, not at all.
All right. We'll pull from other people's confidence in you.
Okay.
Okay?
Oh, I don't know if that exists either.
I'm confident in you. There you go. Victoria is. It feels like the end of like a movie. Or, yeah. I believe in you, Destiny. I believe in you. Everybody's just standing up. Yeah. There you go. Okay. So Destiny. How do I get cosecant? What do I flip?
You flip sine.
You flip sine, so flip it.
It's in the denominator again.
So what could I do to not do that? Think carefully. Sada? Shh. No. It's a very easy thing that we're going to do. Aiden, you said it, but I don't want to emphasize it yet.
Say it louder. Mr. Bates, I don't know.
Don't flip that one.
Okay.
Flip the original. So what is it?
Square root of 233 over 13.
There we go. Destiny, what's the secant of b?
Oh, hold on. Okay. Square root of 233 over 8.
Destiny, what's the cotangent of b?
8 over 13.
You're done.
What the heck? What about Mr. Bates?
It always goes out with Mr. Bates.
It goes without saying.
Yeah, exactly. Kylie, you told me that.
All right, guys. That's it. That's the whole lesson.
math is done.
I'm just minimizing so I can stop the recording. I'll bring it back up in a second.